Step one of the design cycle is to solve the problem. Our problem in this case was creating an arcade game that fit in certain limits. One was a money limit, two, it had to be within certain dimensions, and three, it had certain specifications on what all we had to use.
So the second part of the design process is that we had to think about different types of arcade games we could make. We were thinking about making like a tilted game, maybe a foosball table. We ended up making a pinball table. We went through various brainstorming ideas, making different kind of designs using Google Draw, and also using Paint. And what we came up with was our final design was a pinball machine.
So, step 3 of the design cycle is narrowing down all the various solutions you have into one or two very concrete solutions. Once we had the idea that we were going to do a pinball table, we had to get down to specifics. How big is it going to be? What is it going to be made out of? What's that pinball table actually going to look like? Because you can't just say, I'm going to make a pinball table. You have to have you've got to have the idea of the board, you know. You've got to put all the various obstacles, bumpers, whatever you choose to put in it. You've got to figure out how the plunger is going to work, how large everything's going to be, because as we mentioned earlier, we had a certain parameter. It had to fit that. So we ended up deciding that to make it easier to build, we were going to maximize our space. We were given 2 feet by 3 feet by 3 feet, and we took up every last inch of that space.
Step 4 in the design cycle was the building process.
So what we had to do is we had to get the necessary materials to build the pinball machine. So what we ended up doing is going to Lowe's and buying the necessary materials. We ended up buying a sheet of plywood that was roughly about 2 feet by 3 feet long, and also getting a plexiglass around the same length. And we also bought spray paint to also make it look nice.
Then we took all the material and went to the craft center, and we used the craft center to put it all together. We said we were there multiple days, building and hammering and sawing off the parts that we needed until everything was right. And then after we built everything, we went to my dorm and we spray painted.
Our freshman engineering design day, we had multiple people test our pinball machine, and what we didn't expect is that these kids that have strength as Hulk Hogan. As you can see, we have multiple golf tees spread out across the pinball machine. And what people did is that when we would put the ball in play, they would hit the ball with their flippers, and all of a sudden, the ball would hit the golf tees and it would just fall over right there. And they've broken about maybe 1, 2, 3, 4 golf tees. And so what occurred to me is that we should have found a way to make these golf tees stronger, or maybe drilled it in instead of using wood glue, because that was the wood glue was not strong enough for the force that was.
Another problem we had at Freshman Engineering Design Day was that when we had been playing the game, testing it ourselves, we knew exactly how the game would respond. The kids who were playing it, who were various ages between late elementary school to early high school, had no clue how subtle you were supposed to be with the movement of the plunger. So they would just ram it as hard as they possibly could, and if they did it at an angle, it would kind of get stuck and it would move the entire pinball table, sometimes knocking it off the side. The collection cups that we had to collect the balls when they fell through the holes got moved over the entire time. I was just sitting there actively moving cups for the entire day. And another problem was that sometimes they'd have it so far up that the ball would actually get wedged under the plunger and we'd have to remove the entire plexiglass cover to get the ball out.
We didn't win. But a lot of people did end up playing our arcade game. They found it very fun and entertaining. So I guess that's like the part that really matters.
One thing I recommend for future students is to start earlier. It saves you a lot of time later on, and it will make your project a lot better in the long run.
What I'm going to recommend to future students is that it is a group effort. That means all the group members working together on the project. Not a one-man team, not a two-man team, but a full-man team.
If I had to give the incoming freshmen one piece of advice, I'd have to say plan ahead, plan everything ahead, schedule everything out, because if you don't, you're not going to get anything done until the last minute. And even if you do get a head start, like going to meetings and stuff, you'll end up just like our group. We had meetings, but nothing ever really happened at the meetings until it was like, okay guys, it's time for Freshman Engineering Design Day. We have to make a project. If you schedule everything out, plan ahead, you'll get things done a lot easier, and most importantly, a lot more stress-free.